looking at today just a quick overview of the blackboard shell and what how the assignments are going to progress and what to expect and all that when you're working with the blackboard. Then I'm going to just I'll be available. I'm going to let you work in lab. I'll be available to help you with individual problems that you're having with doing any of the drawings, okay, or the tutorials. So, looking ahead, if by some good chance you are able to, over the weekend between now and Tuesday sometime, and you want to keep moving ahead, you don't have to wait on me, you don't have to wait till Tuesday for a lecture or anything. There are some lectures posted in Blackboard from when I taught the other 100 CAD class, so just went ahead and put those in there so you can use them for review or to move forward should you be ready to do that. So when you're looking at geometric construction and editing tools, in here is where you'll begin using more object snaps, and you've already kind of experienced the trim command. We'll look at extend, and how to flip between those two, and how to use the fillet command. That a fillet is a partial arc, an arc applied to either two lines or two arcs or a line and an arc, that it kind of automatically draws it in there and trims it up and everything all in one step. All you got to do is specify the radius and what the arc goes between. Okay, then we'll be using a command called pedit, okay, polygon edit. It's abbreviation for it. That's the command name. This allows you to take a series of lines and arcs, if you will, that are connected together and convert them into a special line type called a polyline. In AutoCAD, we use a polyline for a lot of different applications to create special shapes that are all connected. So, for instance, this outline all the way around here of connected arcs, I could turn that into a single entity, that outside shape, called a polyline. And that works good for doing sections, putting shading inside of an area, copying it, and reusing the shape. So there's a lot of different ways that we use the pedit or polyline type of drawing. And then, once we've put it together as a single entity, AutoCAD gives us a way to turn it back into separate items again, separate entities, using explode. Okay? So you'll do a little experiment with those and learn how those are used. When everybody listen to me on this, is very, very critical on this, and in your Blackboard, when you get to Chapter 3, in the Chapter 3 assignments, when you're doing the tutorials, kind of similar to what we did in Chapter 1, you're going to do a section of the book. For instance, the first tutorial that you're doing is bisection of a line or arc. Now, the author of the book does not say save that operation as a drawing, but I'm requiring you to do so. So you're required to do this bisection of a line or arc construction, so you're doing geometric construction. That's very, very important to being able to create geometry in a CAD program that is accurate, okay, accurately represents the shape. So a lot of things are automated, but there's a lot of things where you're putting construction together, so you need to know how to do these different operations. So your first one is bisection of a line or arc. You'll do these steps. You'll create this funny looking little shape, and you'll be done when you have bisected, that is, matched up your line perpendicular with the arc and the line. And you would save it at this point, and you'll save it as a TUT-GC-1. Okay, so in Chapter 3, you'll have 7 of those that you do as you're scooting along, learning how to do these geometric constructions. Then you'll finish by doing the gasket. And this is where you'll learn to use the p-edit and the polygon, that is the polyline type of construction, and makes it very easy to create the shape. Once we don't have to do it twice, we can just draw the outline, turn it into a continuous line connected, and then just offset it. We use a command that we can just offset it the thickness that we want, which in this case is a 1/2 inch, and it just makes a copy of it smaller, automatically scales it down. Okay, so so you'll create that, and that'll be your TUT-gasket drawing. So there's 8 total tutorial drawings that you do. Then you've got would help if I turned that on, huh? Then you've got your review questions. So forgot to flip back, sorry about that. So I was pointing at the gasket design. That program should just know that I'm going back and forth automatic, you know. So you'll create this outline shape, turn it into a polyline, connected entities, and then you just offset it this amount, and you create this internal shape automatically. Okay, several gyrations doing that. Then the review questions. Here's another triangle calculation to do, and in this case you're going to measure the area of the triangle and the perimeter, and you do that with one command. It's very easy to do. After you've created this triangle this size, then you'll use the geometry area command that the tutorial takes you through. Okay, you'll learn how to use it, and then we do the area and perimeter of this one. Okay, so they're not right triangles. Okay, they're oblique type of triangles. Okay. Then there's 4 exercises to do. There are tutorial videos on your CD, your video disc that came with the book. Please watch those. Make yourself watch them. The guy, some of it you do need to listen to as well. All right, but he's Chinese. He has a thick accent. Not too bad, but he has a kind of a thick accent at times. So you just got to struggle and listen to it. Okay? Just try to figure out what word he's saying. All right? But watch those, and you'll see how to create that. And I have one that I've posted that's in Blackboard that you want to watch on this one. Okay? But just take time and look at it. It'll show you how to create this shape. All right? So that you're not fiddling around and fumbling around trying to get started on it. Okay? And then this one here, these two, will use everything that you've learned up to this point to create those. Right? There aren't any video demonstrations on these, so if and when you get up to this and you're having trouble getting started, just and it's not coming out like it should, let me know right away. Don't sit there and stew over it and get mad at yourself. I should know how to do this, or the book hasn't told me how to do this. Well, no, it's not going to tell you every single drawing, okay? But all the procedures and tools that you've learned so far up to this point, you'll use them, okay? You just got to put them together. So please let me know if you need help with it, all right? It's not a problem. All right. Now, so there's all the Chapter 3 stuff. Right? That is the tutorials that you post. And their names for each one, TUT-GC-1- your initials. Okay. Then review questions are review questions. And after you post your review questions, then there's a little video review of them. I go over the answers. So after you've posted them to me, then this will become available in here. Okay. You just click into there, and you should see a video, and it will be available after you post your questions to me through Blackboard. Then your exercises, as I said, look at exercise 3-1 in your textbook video disc, and then also when you get ready to do 3-2, I have a 3-part video. There's a lot of graphics involved and so forth, so that's why it's in 3 parts as a video. And then a place to post your 4 drawings down here. Okay. Any questions? That's Chapter 3. Oh, there's a little lecture up in here on Chapter 3. So again, if you want to move ahead, you're done with 2 and you're ready to move on into 3, feel free to click in there and listen to this lecture, 4-part lecture on Chapter 3. All right, Chapter 2, kind of going backwards. It's all ironed out. There is a lecture in there, review. You've already heard about Chapter 2 and gone over it, but by the time you get to it, you may have forgotten some of the things I said. So you can click in there and watch that. I'll have another one posted, another Chapter 2 lecture posted from that I recorded from our class. It will also be available. This is just a generic one I did for my CAD classes. Your tutorial chapter is in here. After you submit your Chapter 1 exercises, then your tutorial will be available. So the process is, you're going to do reading and surveying of the material. You're going to do the tutorials. Then you're going to do the chapter reviews, questions. You're going to go over those yourself and check your answers. And then you're going to do your exercises. Okay? Pretty much run the same way all the way through. The rocker arm is demonstrated in the video disc of your textbook. So you can watch a full detail of it, you know, and you can watch as many times as you need to and scoot back and forth and pick and choose what you want to look at. And your exercises go in here. There are demos of 2-2, -3, and -4. Okay, so you have demonstrations to look at in there at your own convenience when you're ready to do it, or if you need to go back and review the shape's not looking like it's supposed to. Okay, when you have a drawing, thought I had a drawing started up, but apparently I did not. When you are in the middle of creating a drawing and the shape is not necessarily looking like what you want, remember, I'm just creating a general shape here. Remember, you can use the list command. You know, you've created something and you know you were following the dimensions as close as possible, but then when you got done, you looked at it and you go, it's just, you know, something doesn't look the right size, or it's out of proportion, or this is too long, or whatever. Okay, remember, you can use the list command, which abbreviation, the alias for it is LI, and you know, click on a line or an entity, and it'll give you a little kernel of information about it. So it's XYZ location of that line, start point and end point, how long it is, the angle in the XY plane, then to a lesser degree how much it changes in X and how much it changes in Y. Alright? So if you haven't changed your angle in your XY plane, your angle precision to 2 places or 1 place decimal, then you can always look at delta X and delta Y. If it's a 90-degree type line, you can look there and see if there's any change in X or change in Y if it's a horizontal line. Okay? So the length of it and the delta Y for a vertical should be the same. Then if you do a list of a horizontal line, okay, the delta X should be exactly the same. And you might have 3 or 4 decimal places there, so you can check the accuracy pretty close there. The precision of your list will be very accurate. Alright, let's just click on this one up here and list it out. Alright, so up there the length is 1.4977. But the delta Y is 0.0312. The delta X is 1.4974. The angle is showing up as 179 instead of 180. Okay? Because I kind of drew it at a little bit of an angle. So again, this is a way you can go back and kind of check your lengths and your angles and look at it that way. Now, another way to do it, which you'll learn in more detail in Chapter 3, is up here in this panel of the home ribbon under the utilities panel. You've got this measure panel. So you can measure the distance, the radius, the angle, the area, and if it's a 3D object, you can measure the volume. Okay, so you can just click on distance. You got to have some snap turned on. Okay, so your O snap for endpoint should be on as a minimum, if that's what you're wanting to check. And you click 2 points, and then it gives you, well, what do you know? It kind of looks like the list command. Alright? So it gives you the feedback information That's kind of like what list is. All right. Then if you want to know the angle, all right, it says specify vertex. So you can't just pick a line, okay? But you got to specify vertex. So you got to select a line, arc, or specify a vertex. So I'm just going to click on this line, and then I'm going to click on the second line to measure what it is against it, and it comes back and it says 91 degrees. Okay, so it's 91. I clicked here first and then here. Okay, so it's measuring 91 degrees across, you know, with the horizon. I'm sorry, with the vertical 91, because I picked that vertical line. So it's 91 degrees in this corner right here. So it's up 1 degree. Now, notice that it's in whole numbers. So I'm going to type units, command, whoops, escape first, units, and to get my little drawing units box up, change my precision to at least 1 place decimal. Alright, now go back up here and pick on angle, pick, 91.2 degrees. So it's probably even 2 or 3 decimal places out. Again, AutoCAD is very unforgiving. It wants everything connected. It wants perfect angles. It wants all of that to work efficiently and accurately for you. So 91.2 is the actual angle. So as you're drawing, and heck, even after you finish drawing, you think it looks perfect, it wouldn't hurt a thing to kind of click on 2 or 3 entities and measure them. Check their measurements. Okay? This is something that designers in a drafting engineering office, we all check each other's work in the office. Because usually there's so much detail and so much information in a drawing, we have to check each other's work, make sure we didn't get something wrong or miss something. Okay? Because it can happen. There's just like tons of things on a drawing or a design that can be overlooked very easily. So checking your own work, if you're the only drafter, which I have lots of graduates out there in different companies, they're the resident expert. They're the only drafter, designer in the whole company. They have to check their own work. And believe me when I say that is one of the hardest things to do. It's pretty easy to check somebody else's, okay? But it's just human nature. When you're trying to check your own work, you'll miss the very thing that you should catch that you're trying to check for. It's the can't see the trees because of the woods thing. It's a thing with humans. So the way you can best do it is to get away from it. You know, I'm not going to say 24 hours, but you know, like the old saying is, sleep on it and come back. If you got that liberty to do, that's the best, is to actually look at it again the next day after you've had a chance to really sleep on it. There's something happens because you get familiar. It just gets familiar. Now our drawings are pretty simple. I don't think that's going to be an issue. Okay, so check your work and use these tools, you know, to check when it doesn't quite look right, or you know, just to check it, make sure it is accurate. Okay. In creating drawings and working in the engineering department, neatness, speed, and accuracy are the 3 habits that drafter designers have as a goal, as a thing that we have to do. We have to be neat about our work, our drawing work. We may not be necessarily neat in our office. And then we have to be speedy. We have to be have good speed and get things done as quick as possible. But it has to be accurate, because a mistake made at the drawing and design level turns into and magnifies either on the production floor or at the construction site or in the factory. You know, things that are measured wrong, things that are done incorrectly on the drawing can turn into really $1-million losses. Just one measurement off can really throw things, really hurt the bottom line pretty badly. Okay? All right. I'm going to be available up here. If any of you run into any questions or problems with any of the assignments, any of the material, okay, just let me know.